Gravitational waves. This is the topic of discussion in today's lecture. Gravitational waves, this concept was first predicted by Einstein in his theory of general relativity in 1950. According to him, gravitational waves are ripples in the fabric of space-time. Yes, that way the gravitational waves were described in his theory of relativity. Okay, just like if you throw a stone into a pond, then you can see the ripples. So similarity is there in between the ripples formed in the pond water with the ripples in the fabric of space-time, that is gravitational waves. So this way gravitational waves are described. And in his theory, it is also mentioned that when neutron stars or black holes, means these are massive masses, when these massive masses accelerate in the space-time, then the gravitational waves are created and they propagate, just like light or photon particles. But there is one advantage. If you compare gravitational waves with light, you know that matters can absorb and scatter light, but gravitational waves are not scattered and absorbed by matter to that extent as light. Yes, they are scattered, means gravitational waves are scattered and absorbed by matter, but the amount is little. Okay, that is the advantage. If gravitational waves are being used to discover new ideas, new things, new events, then in that case, this property of gravitational waves are beneficial for us. Okay, and yes, theory was proposed in 1950 by Einstein, but just 100 years after this discovery, the experimental verification of gravitational waves were done. Yes, experimental verification of the gravitational waves were done 100 years after the discovery of the theory. Okay, date is 14 September 2015. On this date, a experiment was done. The name of the equipment is LIGO, that is Laser Interferometer Gravitational Wave Observatory. In that equipment, there were two L-shaped detectors. One was placed in Louisiana, and another one was placed in Washington State. And the merging of two black holes that was studied, merging of two black holes, okay, which was 1.3 billion light years away. So according to the theory of relativity, during the merging of the black holes, they must emit gravitational waves, and that waves were detected by this LIGO equipment or instrument, LIGO. Okay, the distance between means scientists found a minute change in the distance between those two places, Louisiana and Washington State, where L-shaped detectors were placed. And that minute change is as minute as a fraction of the width of a proton. Now you can guess how minute was the change. Anyway, that minute change in the distance proved the existence of gravitational waves. So gravitational waves are found when black holes collide with each other. You know that two black holes, in case of binary black holes, they orbit each other, and eventually they may collide, and when the collision occurs, gravitational waves are generated and they propagate through the space-time. Again, during the collision process of two neutron stars, same thing happens. In those cases also, gravitational waves are detected by instruments. Again, during the supernova explosion, in that case also, gravitational waves are generated, but the intensity of that gravitational waves are small as compared to the collision of black holes or collision of neutron stars. Anyway, during the supernova explosion, gravitational waves are generated. So many processes are there. Again, during the birth of the universe, gravitational waves would have generated. This is the idea of the scientists. But those are still not detectable. Okay. So scientists are trying to detect those waves to know many things about the universe at its very beginning. Means during the birth of the universe, I am talking about that thing. Okay. Because that was a large explosion, a vast explosion. So according to the idea or opinions of the physicists, they are assuming that gravitational waves would have generated during that time. Anyway, according to the scientists or physicists, after the discovery of gravitational waves, the experimental discovery of gravitational waves in 2015, that means just 9 years ago that experimental verification was done. So using that concept, using that gravitational waves, we can discover many other things which are still unknown. Maybe new phenomena can be discovered by using these gravitational waves. Many things can be known about black holes, many things can be known about the birth of the universe, many things can be known about the collision of the neutron stars. Many things can be known about the spacetime itself just by using these gravitational waves. Okay, these are the ideas of the physicists, and accordingly they are trying to do their research. In future, space-based observatories are being made. Those things can be used to detect those waves. That means gravitational waves. Anyway, maybe the idea about the universe means there would be a drastic change in the idea of the universe. There would be a drastic change in the reality of the universe. If scientists can successfully use this concept of gravitational waves to analyze all the phenomena of the universe. Anyway, so this was all about gravitational waves. So this is the end of this video. Thank you. Thank you for watching this video.